Okay, folks, well, I can see we just hit 1 minute after the hour, so we're going to go ahead and get started. My name is Matt Thomas, and thank you for tuning in to the USGS Landslide Hazards Seminar. This meeting is hosted by the Landslide Hazards Program and is co-organized with contributions from Stephen Slaughter and Jamie Kostelnik. For those of you that are new to this meeting, you have the ability to submit questions via the chat window or to use the raise your hand feature in combination with your microphone and video camera. We typically wait until the end of the presentation to take questions. And so in the meantime, please just do your best to make sure your microphone is muted when you're not intending to speak. Today is our next installment of a mini-series where we hope to hear from as many state surveys as will join us. These talks will provide an overview of state landslide expertise, focus areas, product types, and introduce some of the most pressing landslide-related problems that the state faces. If you'd like to have your state landslide work spotlighted as part of this mini-series, please shoot me or one of the co-organizers an email, and we'd be happy to coordinate a date. Today we're joined by Dr. Andrew Kozlowski. He's the director of the New York State Geological Survey and Geological Mapping Program, which is a bureau in the New York State Museum. He's a licensed professional geologist with an MS and PhD in hydrogeology, geomorphology, and glacial geology from Western Michigan University. Andrew, thanks so much for joining us today. I'll go ahead and turn it over to you.
Thank you very much, folks. It's a pleasure to be here and to present on some of the quaternary geology and landslide hazards we have here in New York State. Sort of just dive in briefly, give an overview because we are sort of an odd duck here in the sense of where our geological survey is housed. We are within the New York State government system. I'm the geological surveys in the State Museum, which falls under the Department of Education, which again, I think we're the only state geologic survey that's under Department of Education. I think Maine used to be, but they got smart and got out. So I'm a research scientist and I'm a director of the Geologic Survey and the Mapping Program. So that's our organizational structure. We have academic and service aspects, again, towards the public, for public information, education. That's, again, a primary focus. Again, for, health, safety, economic welfare. And we have a number of different programmatic areas which are in various levels of activity that we have going on. I'm primarily, my history with the museum is I've been here since 2006. And again, I have a background in quaternary geology and geologic mapping in this area. So that's sort of who is speaking and where we are. I just thought about this when I was giving this talk. When I was in graduate school in the Midwest and I would tell people I was from New York, almost everybody would universally comment, boy, I don't know how I could never live in a city that big. And I would say, well, no, I'm from New York State. And they go, yeah, it's got to be crazy with all those people. And so one of the things is just a population map here. The state show the populations for the state. And the population is the highest down in the New York City area, down around Long Island, of course, and high in the Hudson Valley over on the eastern part of New York State. And then at a couple of the centers in upstate New York around Syracuse, Rochester, and Buffalo. But there are vast areas of New York State which are very desolate and very low population density, particularly in the northern part of the country here in New York State. So just an overview, it's a lot more rural than a lot of people think. So again, an overview of our overall geology. This is very simplified. I'll just show another one sort of later on. But again, most of the 3/4 of the rocks in New York State are sedimentary Paleozoic, primarily Devonian and Ordovician in age. And then we have some very old igneous metamorphic rocks, about 1.3 billion years old in the Adirondacks, and some older crystalline metamorphic rocks down in the Hudson Highlands, down in the lower Hudson Valley. Physiographic areas in New York State, again, the Adirondack Mountains, the Catskill Mountains, Tug Hill Plateau, and then in a glaciated and fluvial dissected Allegheny Plateau, and many lowlands, such as the Hudson Lowlands and the Mohawk Lowlands and the Erie, Ontario Lowlands. Sort of an overview of New York State, where we are. And we call them mountains out here, but for the folks out west, it's just hills. So our program is based fundamentally on, again, sort of trying to address geology for society. And again, my emphasis is with the Quaternary or Pleistocene geology. And here, like many locations in the glaciated Great Lakes regions, a lot of our landscape is buried by glacial deposits. You know, we're growing our food. We're trying to figure out waste disposal, how to protect water resources, how to protect ecosystems, so on and so forth. So we've been taking and adopting a three-dimensional geologic mapping outlook on things in the last decade or so here at the museum. So a number of years ago, when landslides started to happen here and I was relatively new, I was talking with the time frame. We already had some mapping programs going on, but at that time I was talking with Francis Ashland with the USGS, who was sort of working here in the northeast and eastern part of the state. And I said, how do we go about tackling this landslide issue and trying to map them and figure out these elements? And he gave me some very frank advice, and he said, don't even think about it until you get your surfacial mapping under control. And so that's where we've been for the last 10 years, is really diving in to do detailed surfacial geologic mapping. We map at a 1 to 24,000 scale on individual quadrangles, and then we recompile them into counties once they're done at better scales. So we have coverage for the entire state at scales of 1 to 250,000 for both bedrock and surfacial. But those scales are not really very helpful when you're talking about like a county planning or a county engineer or health department that's trying to mitigate a landslide or better understand what the geology is. So we've been taking this approach, and typically we're publishing these county-wide scales maps at 1 to 50,000 or 1 to 100,000, which we think provides a scale for that still has some usability. But again, we also have the individual detailed quadrangle maps, which are available before we compile the counties when we're doing it. And this is just a sort of an outlook overview of where the mapping we've been done. And our maps are published for free via the All right. So again, it's one of the problems we face as geologists across the board is that it doesn't really matter what we're studying. We face similar problems. And so I've got sort of 3 slides here to sort of pick up where I left off. Again, that I found interesting and have incorporated in here because they sort of pick up with whatever we're doing, whether it's mapping or trying to figure out landslides or groundwater. We never sort of have all the complete information. And so we rely upon things like interpretation. We rely upon things, and this one here is in a mirage that happened off the England last summer, which is kind of fascinating. We see images and we have a perception immediately. In this case, my first perception was that there's this young lady in the photo perhaps had a disability or had prosthetic legs, but in fact she's holding a bag of popcorn that is the same exact color as the background grass and so on and so forth. So it's playing tricks with our mind. And the other one that we're constantly dealing with is the issues of perspective and scale. So that is my dog, but that dog is not that big. So as we speak here again. All right. So again, I gave you fair warning. I'm a Pleistocene Quaternary geologist. So just to be thorough and cover the sort of aspects of that, the Pleistocene epoch. Again, about 50 million years ago, climate starts cooling, and then about the last 5 million to 2.6 million years ago, the climate really gets wonky, and we go into these icehouse, greenhouse conditions across most of the northern latitudes. Something that's been very common in New York State and in many places is that the glacial geology is oversimplified. And so here's an example of a conceptual groundwater model, and all of the glacial deposits have been characterized as either drift or overburden. So this is one of my favorite pictures from an EPA model, just sort of showing this oversimplification of it. And again, other states are further ahead than us in many places in other states. For example, here's a diagram from 1960 from the Illinois State Geologic Survey. Again, radiocarbon dating had just barely been out, but this is what is known as a time and distance diagram, where they were trying to understand these Pleistocene glaciations, understand the extent and the aerial extent of where glaciers were and their chronology and their timing, and establish their overall stratigraphy. They identified certain important stages that were then recognized by other states throughout the Midwest. But one of the problems we still have is that the geology stops a lot of times at the state boundaries. So what system's been established in one state doesn't necessarily correlate to other states that have been done. So some events or work has been done more recently to try and correct or move forward with some of that. This is a recent publication from GSA on Quaternary glaciations. It's got several articles in it, but here is again a modern updated article from the Illinois Geological Survey where, again, they've gone as far as they have lithostratic control. They have members and formations of their Pleistocene units that they've worked for, and by doing so, they've been able to then develop time and distance diagrams that are more modern, with a better understanding about the extent of past ice sheets. And that's important because a lot of these past ice sheets are affiliated with large proglacial lakes. and bodies of water and drainage, which ultimately result in lots of fine-grained sediments that can end up being problematic for slope failures as society builds over those materials. Here in New York, the last real attempt at this was done in 1993 by Ernie Muller and Parker Culkin, and it was based largely off of radiocarbon dates from the 70s and the 80s to sort of establish control, and that's sort of the limit of what's been done largely for New York State. Elsewhere in the region, this is a diagram, again, from Paul Caro out of Canada, and it's a time and distance diagram showing, again, from Cochrane, Ontario to Cincinnati, Ohio. These sort of spikes to the left of the diagram on the screen are sort of further to the south, and they've got radiocarbon control, and they're showing the oxygen isotopes. All right. So anyway, the point of my slides before I bailed on all of you folks, and I apologize, is we don't have an understanding of chronology. We don't have an understanding of stratigraphy in New York State. And that's what we've been working on. And that's why we've been mapping where we have been mapping. Again, continued overview of our state with a bedrock, slight dipping Paleozoic rocks throughout much of the state, but it has a big impact on our Pleistocene glaciations. So if we looked at a cross section across New York State from Ontario to Pennsylvania, we'd see that the rocks are largely dipping slightly to mostly the south and slightly to the west across the plateau. Again, we have lots of these limestone escarpments across New York State. And the end result of this is that basically, again, it has impacts with overall deglaciation. So overview of glaciation, according to our typical mapping of what we have, is that during the late glacial maximum, again, all of the states covered with ice except for a small part of western New York, southern Long Island. The Laurentide ice sheet, sort of rifle through these, try and get caught up a little bit. There's a period of time known as the Erie phase, where the ice deglaciates out of the Finger Lakes region completely and restores drainage to the Mohawk River Valley. And then the ice re-advances at the stage known as the Port Bruce, or forming the valley heads moraines, which is important because it creates the modern drainage divides between the Ontario Basin and the Susquehanna River drainage systems into Pennsylvania. So the ice is re-advancing during this period of time. And then, of course, as it retreats back off of those bedrock escarpments and it's carved out, it creates these small sea-sized proglacial lakes, very large proglacial lake systems trapped between previous bedrock topography and new areas that have been carved out by the glaciers in these glacial lake basins. And so, again, these various different lobes across New York State are establishing this multitude of proglacial lake systems across the landscape. And again, lastly, there's oscillations of ice advancing back and forth. This is a sort of an estimated chronology coming out of New England based on the New England VARF chronology. And so another point to all of these slides I've been showing you about chronology and saying we don't have them, what we do have is that none of them match up with a larger scale global record of ice ages, such as those recognized by deep sea cores and in the ice cores from Greenland, so on and so forth. So again, we now recognize that we used to think there's only 4 or 5 glaciations, but we realize that there's this oscillation in the last 2.6 million years, right? And we've got all these glaciations and conditions possible for glaciation, including about 102 of these MIS, marine isotope cycles, across the northern latitudes. But we don't know or recognize individually often the sedimentary packages left or preserved or available still to be engaging with society as we build over these deposits. And so the last most recent one of these is MIS2. All right, on to some geology photos. So these are typically what a lot of our upstate New York outcrops look like. And this is along streams where we have a lot of our slope failures. We have lots of laminated lake sediments. They're often interbedded with other deposits. Showing sort of field photos here. I'm going to rifle through these again to get caught up. Again, for scale. And in these photos, we've got, again, multiple glacial till units, multiple lacustrine units, silts. Here we are collecting a sample for our optically stimulated luminescence dating, trying to get a handle on chronology. And so here's basically, right, we take our field data, we transform it into this. And then, of course, we have all these blue colors, which represent glacial till units. And as I've just dazzled you with all of this chronology and this oscillation of ice fronts, which glacial till unit corresponds to which glaciation? And this is part of our three-dimensional puzzle or game we're playing here in New York and other places in New England as we try to understand the 3D framework of these glacial deposits. And just as another example of this, here's a photo of some really indurated, tough lacustrine sediments. These lacustrine sediments have actually been faulted. There are a couple of locations, but they also preserve some fantastic structures, such as some very nice ripples, so on and so forth. So this is typical from the outcrops we would see and work on, except that in this particular case, in these ripples, we've recovered Arctic plant remains, Arctic tundra, dryas, and salix leaves, which are basically about almost between 35 and 40,000 years old, which tells us that this lake sequence is actually from MIS3, or it's a lake sequence that was established before our most recent glaciation. So understanding chronology is really important for our framework as we move forward with our mapping. The other thing that's been really helpful as we've been going forward, like it has been in all states, is the advent of LiDAR. So here's a LiDAR image that I would have used in graduate school in the late 90s. And that was a 10-meter DEM you're looking at. And now, of course, we have 1 and 3 meter scale LiDAR images that show us moraines and all kinds of hummock topography and spillways and streamline landforms. That makes our job a lot easier than it used to be. Landslides in New York, where do they occur? Everywhere. But there's a couple of key locations where they've occurred with greater predominance, greater prevalence. And that is the Hudson Valley location and in the Adirondacks, which is what I'll focus on with these next couple of locations we're working through in these slides. We estimate that there's about 100 to 400 landslides annually in New York State. Most of them are extremely small, typically under 2 acres. They almost all go unreported because unless they're affecting a road, that's when our Department of Transportation would get involved and call us or let us know. They're on private property. We're not regulated. We're prohibited from working on private property. Again, a lot of these go unreported, but we know that they cause many tens of millions of dollars worth of damage annually, whatever the process may be. And again, some of these landslides in New York are fatal. So we've had a total of 52 fatalities since they've been recorded. Again, most of these locations are in the Hudson Valley. And many locations, I'll circle back to some of these sites a little bit later in the talk as I rifle through things. Our landslides are probably small compared to many states, especially out west, but these are sort of the big three. Again, 82 acres, 75 acres, and 53 acres. I'm going to spend some time talking about the Keene Valley slide and show you a couple of photos of this more recent slide from Tully Valley. So again, as I've talked about before with the glacial landscapes and these things, the problems we're facing here are associated with glaciers that are trapped in valley systems again. If they haven't formed proglacial lakes, so again, the ice is advancing down, builds a series of different moraines, sometimes small-scale recessional, sometimes large-scale thrust block, or sort of just large-scale moraine systems. And then when the ice is pulling back out, we're creating these moraine sediment threshold-controlled ice-trapped lakes, or if they erode through basically a series of sediment, they may encounter a bedrock threshold, and then ultimately, if the ice retreats far enough, it will simply find new outlets. But we have the ability to put a lot of fine-grained sediment high on the landscape as a result of this, and that's sort of important overall. So again, here's sort of this overall footage of deglaciation with these proglacial lakes, and the net result is that we have lots of lake clays spread out across New York State. And this is a very generalized map, so on and so forth. This is the 1993 Tully landslide, which was classified as an earth flow, a rapid earth flow system. The dashed line in the photograph that you're looking at is a road. It's completely buried. There's a house over sort of on this portion of the screen here. This house was located on the other side of the road before the landslide happened. No fatalities occurred with this landslide, but a lot of displaced houses and quite the mess taking place. Again, these were in glacial lacustrine clays and some of these steep wall valleys throughout the Finger Lakes area of central New York State. And again, just sort of going back through, moving into sort of the Adirondacks and that area. So this is a general map of the slope of New York State, and the highest or steepest slopes in New York State occur in the Adirondack Mountains and in the Catskill Mountains. And so we zoom back into this next story, which is related to a slide that was a little bit famous about 10 years ago in the Adirondacks. So a couple of things. The Adirondack Park is something that's talked about a lot here in New York State. And it's confusing because it's not all public land. All right, so it's about a 6 million acre area. Half of it's privately owned. There's lots of villages and towns, and it's got a very sort of low round or year-round population, given the size and scope of the area that it contains. Regulation and permitting in this area is controlled by a governmental authority. It's administered by the governor's office. So the governor's sort of authority often can supersede whatever regulations and permits that are issued by towns and villages, which leads to all kinds of happy, warm, fuzzy feelings sometimes by residents in these small towns. So this is just a sort of, again, my talk is focused on glacial Pleistocene slides, but this is a typical slide we would see somewhere in the northern Adirondacks, or rock slides. Again, this is near Whitehall and in sort of the eastern edge of the Adirondack Mountains, showing a typical road blockage from sort of rocks that are sort of dipping or jointed facing the road systems. Again, again, smaller in scale compared to probably many slides out west or elsewhere, but a pretty good sized rock slide for here in New York State. Landslides in the Adirondacks, there's a fair history of these things. The vast majority of landslide events that occur in New York State in the Adirondacks are related to these Debrisslides or debris avalanche type slides that occur. They're almost always associated with tropical storms or hurricanes. You can see scars. This is a sort of a Google Earth image of a giant mountain in the Adirondacks, and you can see the slides from the avalanche debris flows there on the mountainside. Again, very quick, very rapid events when the soils get saturated and loosen all the trees and rock comes down on the landscape. However, in 2011, we had a completely different beast that developed, known as the Keene Valley landslide, or sometimes referred to as the Adrian Acres landslide. This is the largest landslide in New York State history, about 82 acres in size, and it was right up on the high peaks, some of the highest slopes within the Adirondacks. And there's a bedrock ridge at the bottom of this illustration, and you can see the road systems from where they're housing as it's been developed. One of the things that's happened in the Adirondacks that's like other places is that the number one go-to destination is lakefront property. But as the lakefront property gets purchased and taken out of the market, the next place is places with a view. And so when you have lots of high mountains and steep slopes, you can get some spectacular views, which has led to development on these steep slopes, which is largely unregulated in New York State. So this is, again, a footprint of the Keene Valley landslide. Again, it's not necessarily the steepest part. It was activated around sort of May 1st of 2011. We received some phone calls that there was some slopes had moved, some houses had maybe shifted. And so we went up into this region to sort of look at this again. And red is the head scarp, and the bottom is the toe in blue. And just a couple of other angles to sort of show it's, again, relatively not as steep as other parts on the landscape that you might see, all in all in general. This was sort of occurred, or again, right around May 1st, we would say. So there's a typical precipitation for this region that we would see. Again, you can see the average, the record, and then, of course, the precipitation for 2011. That particular winter, we had a very high snowpack from some late winter storms. So we had some pretty good rain on snow events up in this area that may have been part of the partial trigger for this landslide to occur when we were looking at the area and working on it. So that's sort of the precipitation events. As we dove in more into this, there was other sort of pre-slide indications as we began to talk to people. That home number 1 you see on the screen was destroyed. Home number 2 was damaged, I think ultimately abandoned as well. Home number 1, people began to report that their windows and doors have been sticking for some time, right? Kind of classic signs, and that there's something was going on, but they were just sort of seasonal homes. This home was built back in the 80s in this particular location. So the context of the landscape, where there's Keene Valley sort of located there. Giant Mountain is another one that we're looking back to in a moment here, but just for reference. So we're at the intersection of these branching streams, the east and the west branch of the Ausable River flowing into Lake Champlain. But during the Ice Age, the last deglaciation, these drainages were blocked. These north-flowing drainages were blocked. There's Giant Mountain again for reference. And so the Keene Valley area is right over here on the slides. And then this large lake, Lake Chapel, formed, which may have been as deep as 800 to 1,000 feet in a couple of places. So it's an exceptionally deep proglacial lake trapped up against the high peaks of the central Adirondack Mountains in this location. So here's just some slide features related back to the landslide. Again, the head scarp that developed pretty soon after the slide itself triggered. Again, photos, it was really very active in the early parts of May and through June. Again, sort of typical spreading of these tension cracks, the surface of the top of the slides scale. This slide is interesting because it shows some of the trees that are splitting where the trees grew, and in this particular slide, it's interesting because it's growing on the older scarp. There was an older scarp at the top of the slide feature, geomorphic expression. A couple of the trees had fallen on some homes. When the trees were cut down, we counted 100 plus rings. So the trees had been stable on the scarp for at least 100 years. It had not moved. In this case, this was sort of a very slow moving, or doesn't reactivate that often, so to speak, for the size and scale of this particular landslide. Again, lots of boulders and showing sort of the toes of the slide moving back and forth. There's the toe of the slide again. A colleague in a poncho there taking measurements. Again, the toe in the woods of the slide is creeping forward in late May to early June. Again, there's Bill Capel with the USGS standing by an active portion of the toe moving through the woods. It was moving anywhere from 5 to 6 centimeters a day at first, and then was gradually slowing. So it was moving at a pretty decent clip early on. Again, more pictures of the toe, a truck for scale. And there's a progression that you can see on the slide of this house that was ultimately destroyed, rotated, sheared on multiple ends, moving back down for scale. Some other movement along the side where you can see that the foundation is buckling and rotating, and the actual piers just crumbling as this rotation of the slide continues downhill. That's the driveway to the house that ultimately was condemned. Again, the scarp here in the wintertime, you can see on the screen here, perhaps, right there where the snow is breaking. Another photo of the houses. These are large, often mansion-style homes. A lot of these people are from Long Island, a city, Connecticut. They come up here and build these sort of staggering houses up on the very steep slopes of the mountains. Again, another example of sort of the scarp that developed looking off towards Giant Mountain to the east. And again, some of the slides showing the propagation of this head scarp that developed. So this is May 11th. There's a set of stairs, which will be referenced again in the future here. And again, this is October 24th. So this sort of slide really dropping and moving throughout the early summer months when it was pretty active. And again, February 29th of 2012, seemingly somewhat stabilized this location. Again, other progressions, you can sort of see the foundation of the house here on this large scale house here dropping like a rock, literally, through June 3rd. And ultimately, this ended up resulting in this particular location. This is a 3,800 square foot, what I would call a mansion or home, that was ultimately picked up off of its foundation. The slide is right behind this house. This house was picked up. It was moved and relocated approximately 300 feet and set on a brand new foundation at the top of the property. So this is again 2011. The house set on the new foundation. The house sold again in 2020 for $590,000. And again, just a map, an overview of the slides and the slide footprints and sort of the directional vectors we picked up from sort of some creep stations and other types of instrumentation we were using to sort of take crude measurements with along the lines. This is a video we collected of movement on the slope, which hopefully you'll be able to see here again, moving downhill. We're off the slide, we're on a fixed object off the slide here, moving back through, creeping down slope. And there's my colleague again for scale. So very large boulders, very large sort of objects again on this overall mass moving down slope, so to speak. Here's our movements, including rainfall and movement sort of diagrams again. And one thing you'll see here is that early on, again, movement is sort of raging pretty well. And then as we get right around this sort of first part of July, again, overall movement starts to really decline dramatically. You'll also see the brown curve, which has a pretty good stair step in it around the 31st of August in 2011, which is interesting again because that is a storm of pretty good magnitude that was associated with a hurricane that came through the Adirondacks and triggered dozens and dozens of debris avalanches, but did not cause this slide to reactivate like we thought it was going to do. Again, a lot of characterization on the upper parts where we could get access to the property. Again, it's a mix of private and public property. The lower part of the slide was an area that was purchased by developers that wanted to develop it, and they did not want us operating or collecting data down on the lower slopes. So we were only be able to work where landowners would give us permission and they want our help to sort of gauge what was going on if their houses were going to sort of make it. So some over locations, again, monitoring wells were installed to monitor groundwater levels. Just again, the characterization of this, and then our overall net characterization. So despite being able to see bedrock almost in every direction, we drilled to depths of 65 feet with hollow stem augers, and then basically could not get any further down. The drilling conditions became difficult. There was concerns about drilling into some sort of artesian conditions, perhaps. So we abandoned these at the top, but ultimately, again, being able to literally look 100 yards away and see bedrock outcropping, but lots of these sand and laminated silts and clays in this particular location. So this is sort of our upper characterization based on a few wells, but just to put this into perspective, this is, again, compared to what the overall slide was in its overall dimensions, showing a hypothetical failure surface. There was an older, very deep well at the bottom of the slope that we had access to initially. Eventually, we lost access to it because the kink from the slide caused the casing to shear so much, but we could measure the location of the sheared well casing to estimate where that shear surface came out down below. But again, we're unable to collect any subsurface information on the actual failure itself. So this is our groundwater level measurements. We monitored this for about 3 to 5 years after the slide. When it first started again, and this is the Hurricane Irene, again around August 31st. Again, really quite a storm. We really imagined it was going to reactivate the landslide that didn't, which is kind of fascinating for us because it's got obviously some very complex sort of groundwater trigger mechanism going on that we were never able to fully quite deduce in this location. And again, just showing again the overall groundwater elevation levels and precipitation events, sort of the storm of record coming through at this location that did not reactivate the slide. So again, movement, water table, so on and so forth in the slide. Ultimately, we ended up doing surfacial geologic mapping. Again, in the Keene Valley quadrangle as part of our solution to sort of address this and provide some additional information for the local planners. There's the map itself and cross sections. Again, one of the things that was discovered as we continued upstream in these mountain streams are that even locations that were really, really high, much higher than ever before believed to have been able to contain sort of proglacial lake sediments, we would commonly find laminated proglacial lake sediments high up in the mountains, right in the sort of the edge of the high peaks. There's some of these laminated lake clays that are overlying sort of alluvial boulders, probably from a pre-glacial time frame, something along those lines. So again, moving back to the lake clays, that was the Adirondack story, and then now looking at these generalized lake clays throughout New York State, looking back a little more detail on the Hudson River Valley, where we had Glacial Lake Albany, which was again extensive throughout the Hudson Valley, and has affected locations in Albany and Troy. Those are the two major cities here in the Capital District and Schenectady. At one point in time, there was 131 brickyards operating within the Hudson River Valley. Back in the 1800s, it was the principal source for bricks in the Northeast. This is some old photos showing how it was done back in the day with horse and cart. They'd lay the bricks out in the day and let them dry for 3 or 4 hours before they got them off the kilns. Sort of a very labor-intensive process. And this was also an outcome largely because New York City kept burning. I think it burned down 3 times before they started to mandate the use of bricks as a construction material. So there's your sort of an urban photo again of a populated area. That blue rectangle represents a typical sized 2 acre or so landslide. Just for example, that's the Keene Valley landslide by comparison. And just as an example again of our slides that we see down here in the Hudson Valley, and these lake clays. They're large, often multiple rotational failures. This is the 68 Mahar Road slide along the Normanskill River, which is a stream system that's been sort of incising itself through these glacial lake clays and silts since Lake Albany drained. The time of drainage of Lake Albany is not exactly well pinned down. There's cars for scale buildings. The building you see in this photograph on the left was abandoned probably 15 years ago, and we don't know exactly why it's still for sale today, but we suspect there may have been foundation issues that were noticed, and it was put up for sale and has not been resold, sitting there vacant to this day. Again, some nice LiDAR imagery showing the Normanskill River and the location of that slide from Mahar Road. And again, in lots of these steep meander bends, we have some places we have 10 to 50 feet of sand, often dune sand that is developed and blown over. So there's dunes up on the upper part of this LiDAR image that have overlain, which is nice. The sand itself drains until you get into the lake clays that are underlying everything. There's a close-up of the Mahar Road slide. Over here on to the left of the main road, you can see other slides taking place as well. On Delaware Avenue in 2000, another large slide, these glacial lake clays that shut down ultimately, again, State Route 443, which is a main artery into the city of Albany, until it could be rebuilt. There was a building and a vegetable stand and a parking lot that was lost. No fatalities, fortunately, in this location. These are exceptionally common here in the Capital District, in these glacial lake clays, and also in the Hudson River Valley. Here's a LiDAR image of Troy, New York, showing you can see that the population density is very built up on these lake clays throughout the Hudson Valley. This is the location right there of the 1843 Mount Ida landslide that was responsible for 17 deaths in that particular slide. And then in 2011, during Hurricane Irene, the same hurricane I mentioned to you folks earlier for the Adirondacks, triggered a number of landslides along Route 2, again in these glacial lacustrine clays which have been built over, and the result was the loss of numerous houses from these sort of rotational failures moving back down on the landscape. So some other slides showing pre-Irene, Hurricane Irene, post-Irene house displacements on the landscape, so on and so forth. So another factor that is sort of makes me a little bit nervous about things is the distribution of overall earthquake activity. We don't have a lot of very large-scale earthquakes, particularly like the folks in California who had sleep through almost all of these, but we have enough. We have sort of one documented landslide triggered by some seismic activity, but I think it's really just been a matter of luck given the distribution of lake clays across New York State. So one of the things that I thought about when we were doing the work in Keene Valley and some of the work done elsewhere in the Hudson Valley is a lot of our landslides end up happening at sort of when we have the end of winter, March, April, right? The snowpack has been melting off, groundwater super saturated. Maybe we'll have a large scale rain on snow event. And to my mind, it's always wondered if we ever had a decent seismic pop at the end of March or the first part of April in the Hudson Valley, down in the New York City area. That could be very bad given the distribution of lake clays we have in New York State for large areas. So I think that's been a potential trigger mechanism that we've just dodged a bullet here for a long time, and hope we do continue to do that. But again, I think additional surfacial geologic mapping would be helpful for that. So sort of in summary, again, the Keene Valley landslide represents sort of one of many types of slope failures we see in the Adirondacks. It's a different beast. It has got a slow-moving juggernaut style triggered by some combination of snowpack and groundwater movement. We later on discovered by some of the landowners that the houses up there have a collective singular well that puts water into a large cistern, and that well and that cistern then distributes water to houses. The houses are not metered, but the individual water mains to houses have frequently break over the winter when people are not there. And so we have no idea if that had occurred or if there had been large losses of sort of contributions of groundwater in addition to precipitation or snowpack melt that helped to be the straw, so to speak, that broke the camel's back and triggered this Keene Valley landslide. But most of the landslides are these debris slide type phenomena that occurred with tropical storms throughout the area. And a lot more geologic mapping of the surfacial deposits would come in handy, particularly in light of development pressures that are occurring in the Adirondack Park and other locations. The LiDAR data, again, is really absolutely essential to sort of identify sensitive areas or areas prone to previous slides. And again, landslide hazards are going to absolutely continue here in the Adirondacks and the Capital District. One thing that's been predicted is here in the Northeast is that precipitation values may increase by upwards of 50% in the coming decade, so to speak. And so, or not decade, the coming 50 years here. So our landscape has basically been in equilibrium for the most part since the glaciers left. And with climate change, we may be shifting that equilibrium and throwing all of this completely off balance. And there's going to be a natural readjustment, especially in these areas prone to lake clays. So I think we're going to see a lot more slope failure in some of these populated areas within the Hudson Valley. And again, seismic activity as a trigger is something that's of interest and we should be probably more aware of. All right, I'm going to sort of try and be quiet now and hope that you folks have seen the show and everything